Hi everyone, this is Soumyadi Paul, a mentor at Code Cardos and a software developer at Amazon. And welcome to day 4 of our system design series. Now, in the previous video on day 3, we learned what is latency and what is monolithic architecture. Now, we learned that there are mainly two types of architecture. One is monolithic architecture. So, let me write it down here. So, there are two types of architecture. Okay. One is monolithic architecture, and I hope all of you now know what is monolithic. If not, please jump onto that video and look at that video. Okay. And the other is microservices architecture. Okay. And trust me, it's not that right now only microservices are used. Even monolithic is very highly used, and both are equally popular. It's just that their use cases are different. So in some places monolithic is used, in some places microservices is used. Okay. So we have already understood what monolithic is, what monolithic does, when to use it, why to use it, what are its advantages, etc. Now today let us study what are microservices. So there are two levels of microservices actually. Okay, there are two levels. Now in the previous session, in the previous video, we learned that monolithic basically means that we have the UI, which is the front end, the back end, also called as the server or the business layer, and the storage layer, also called as the database layer. All of them are together in a single server, Okay, their entire code bases are together. Their deployment is happening together. They are in a single server. Everything happens together. The first level of microservices says that now they are in separate code bases. I have a separate code base for UI. I have a separate code base for server or backend. I have a separate code base for database. All of them are deployed and running in their own servers. Okay. This is what microservices at level 1 means. At another level, it means that for complex applications, for complex web applications where there are many big features, almost every feature is developed as a separate web application. So this server, which has our business logic, okay, or this UI, they may be different for different features. So maybe for feature 1, this is its UI, server, business logic, and database. Maybe for feature 2, I have another set of UI, server, and database. Okay. Maybe for feature 3, another one. For feature 4, another one. So what is happening is, feature 1 has its own separate UI, its own separate server, the backend logic, its own separate database. Feature 3 also has its own separate UI, own separate server, own separate database. And they're all deployed separately. Even inside a particular feature, the UI is deployed separately, the server is deployed separately, the database is deployed separately. In feature 2, the UI is deployed separately, the server is deployed separately, the database is deployed separately. Similarly, in feature 3 also the same case, in feature 4 also the same case. So each of these parts of a feature are deployed and maintained and handled and coded all in a separate manner. Okay. Now this division of features is something called as single responsibility. This is called as single responsibility. Okay. And this is the key takeaway from microservices. This is the principle of single responsibility is what microservices are built upon. Okay. So the principle of the principle of single responsibility says that every feature has a separate service Not exactly feature. There may be a few clubbings, a few features clubbed into a single service, a single application. Okay, it depends on how complex that feature is. How many do you want to club, etc. But every feature has a separate, or is, every feature is a separate web application. Are you getting it? Every single feature is treated as a separate web application. Okay, with their own UI, database, backend, etc. Now, some web applications may not have UI, maybe having some shared database. That is a different thing based on our business use case. Okay, but this is what microservices is. That every feature has a has a separate web application, a separate service which serves a single responsibility. For example, let us talk about Amazon. In Amazon you have a lot of things. You go to Amazon, you list the products. So maybe when you're listing the products, there may be one service called as product service. Okay, or I can also call it as inventory service. Okay, so now whenever you view a page, the products page, or search for a specific product, Amazon might need to ask someone that, hey, how many products of this category are remaining? Is this particular product remaining? What is the quantity of the products remaining? What all products do we have, etc. So, so inventory service can be a separate service. Now, inventory service may not need a separate UI. Okay, it can just have a server and a database. So inventory service will have a server deployed separately, a database deployed separately. And inventory server in totality works as a separate web application. It works as a separate web application. Okay. Now here, the job of this web application is to store all the product related details. Which all products are there, what category does it belong to, how many quantity of that product is available with the seller in their inventory, what are the ratings of that product. Okay, description of the products, name of the product, images of the product, storing all these data in the databases, and also providing, if any other service, any other web application, if they want the answer or if they want some data. Or maybe you have to update the ratings, you have to update some new products. If the seller is coming and updating the quantity of a product, if the seller is coming and updating more number of products, more types of products. So handling and dealing everything with the products is done with the inventory service. There might be something called as the authentication service, the auth service. The auth service may have a UI, it may have a server, it may have a database. The auth service is a separate web application, a separate service that kind of behaves as a individual web application. It deals with sign in, sign up, Google authentication, forgot password, etc. All these authentication related stuff. Okay. Then suppose you have another application called as the payment service. Payment service. This again may not have a UI, this can just have the server and the database. Okay. And it deals with the payment part. Then you can again have something called as the what are the things do we need? Maybe a user service, a user service. Okay. It stores all the users' details, their mobile phone, their username, email address, their past orders history. Okay, everything, what will have they bought, everything. It stores everything related to a particular user. Okay. So this inventory service acts as a separate web application which deals only with products. Auth service is a separate service which acts as a web application which deals only with authentication related stuff. Authentication and both authorization. Payment service is a separate web application, is a separate service which behaves as a separate web application and deals only with payment. User service is a separate service which behaves as a web application that only deals with user related stuff. So this way of designing your entire web application, and together if you see together, all of them together is what makes something like an Amazon. Okay. So this process of dividing your entire big application into multiple smaller chunks of smaller applications is called as microservices architecture. Understood? This is called as microservices architecture. So what is it? The process of designing the process of designing an entire web application into multiple smaller web applications, into multiple smaller services or web applications, services, is called as microservices. Okay. Now, let us see what are some advantages and disadvantages of this. Okay. Now, obviously, there are some advantages. Now, what are the advantages? The very first advantage is that selective scaling is possible. Selective scaling is possible. So that now you see that, okay, maybe a lot of people are suddenly coming on my website and they're looking for products. Maybe the buying is not happening that frequently. Okay. Maybe new user addition is not happening that frequently, but just the viewing of products has massively increased because I may have done some sale or some marketing gimmick has worked, etc. So I may want to have some more number of servers, some more number of specifications to support my inventory service only. So I can scale up my inventory service without scaling up my auth service, payment service, user service. So this saves a lot of cost that I can specifically scale up or down a particular service, a particular smaller web application based on where my traffic is going. Okay. So this is called as selective scaling is possible. There is loose coupling. This is called as loose coupling because each of them are independent. There is loose coupling. Loose coupling means services are independent. Loose coupling means services are independent. Okay. Services are independent. Okay. There is loose coupling due to the principles of granularity. Okay. Of granularity, and that is also called a single responsibility. Okay. Every service is different, is handling a separate responsibility, is not impacted by anything that is happening to other service. And due to this, I can say that changes in one service does not affect the other. Changes in one service does not affect the other. Okay. Because they can be treated as different web applications and this development can happen in them separately. Okay. And the third advantage is that each service can have a different tech stack. Okay. Can have a different tech stack. Okay. So maybe inventory service is written in Rust. Maybe auth service is written in Spring Boot with Java. Maybe payment service is written in Spring Boot with Kotlin. Maybe user service is written in MERN stack, etc. Each of these services are independent of each other. They're loosely coupled. They're granular. They handle a single responsibility. They are not affected or impact other services. So each service can be scaled more or less based on the traffic on that service. Each service can be deployed separately. Each service can be developed, coded separately. Each service can have a different tech stack. Okay. Now, there are also a few disadvantages. There are also a few disadvantages. Not everything is great. There are also a few disadvantages. What are they? The first one is that a costly infrastructure. Obviously, if you're having so many servers, and so much of division of task. You need a lot of infrastructure, so it makes it a little costly. Okay. Second thing is integration testing is difficult. Obviously, if you have multiple web applications, and if you want to test the entire user flow, which uses maybe the auth service, the product service, the user service, the payment service, etc., then you have to do integration testing, which means testing of all the services at once together, one by one in a continuous user flow. Okay. So integration testing is difficult means testing of the entire user flow becomes difficult because now the entire user flow involves multiple services. Okay. Then again, yes, security is difficult. Obviously, if you have multiple so many servers, their security, handling their security is also a difficult task. What else? The last will be higher latency. Okay. As I taught you that if we have monolithic architecture, every service, everything is inside one server. So multiple services or multiple APIs or multiple parts of the web application can communicate with each other through process to process calls. Here that is not the case. This entire thing, inventory service is in a different server, auth service is in a different server, payment service is in a different server. So if my inventory server wants to talk to my database, they both are in different servers, they need some API calls, request response cycle. Suppose my inventory service is asking for, or suppose my auth service is asking for the user service, then this also happens like this. Suppose my inventory or my payment service wants to call the inventory service, then an API call happens. So why is latency high? Between communication happens over the network calls. Communication happens via over the network calls. Over the network calls. Okay. Over the network calls. Okay. So these are the advantages and disadvantages of your microservices architecture. Okay. I hope this is completely clear to all of you. I hope you guys have gone through the previous video, learned what is monolithic architecture, and now in this video you have learned what is microservices architecture. Okay. So that's it for today's video. I'll see you all in the next video of our next video on system design series. And if you want to learn these concepts in a much more impactful and much more in-depth manner, do join CodeGardos, where you'll be taught by mentors who are working at Amazon, Microsoft, Google, just like me. Okay.